Welcome back, folks. In today's class, I'll be talking about the chapter number 15. And in the chapter number 15, I'll be focusing on chapter 15.2. And I'm going to right now take the example 15.3, which is on page number 763. And in this example, we're gonna try and understand how we can balance out the gravitational and electrical forces. Now, so let's look into the question. So a question says that there is a mass of oil droplet which is equal to 8.2 times 10 raised to the power negative 15 kg. I'll recommend you guys to pause the video and open up the question so that you can actually understand what the question is asking for. So oil droplet is given to me which has a mass this much, and then it is suspended in the electric field. So electric field amount is given to me which is equal to 1.0 times 10 raised to the power 5 Newton per Coulomb. And also we are provided that it is suspended in air. Suspended means this charge is not moving up, neither moving up nor moving down. So there are equal and opposite forces which are acting on this oil droplet. And I wanted to find out how many electrons this oil droplet has gained or lost. How many electrons gained gained or lost. So how can I first of all figure out the electrons gain or lost? So if this oil droplet comes out to be a positive, then the electrons are lost. Positive on charge on the oil droplet, lost electrons. Negative charge, if this oil droplet comes out to be a negative, then the electrons are gained. Now, before I jump into this solving of this question, I wanted to tell you the book has done this question a little differently. So if you are one of those students who love to reading from the book, then I'll recommend you to do this all these questions from the book. Don't look into this video. Or you can look into this video also and then look into the book and then decide whichever method you like and you can follow that method. Now, let's solve this question. So, as I said, we are given that there is an oil droplet which is suspended in air, and we wanted to find out how many electrons gain or lost. So, there are two plates. One is the top plate, another is the bottom plate. And I wanted to first of all find out what is the charge on top plate and what is the charge on the bottom plate. That can be figured out by the direction of the electric field. So electric field given to me in this one is in the downward direction. So if the electric field is in the downward direction, we can recall the chapter number 10 for electric field. This is how we represent. For a positive charge, electric field is always outward, and for a negative charge, electric field is always inwards. So electric field always moves towards the negative charge. So this down here where the arrow is pointing, I will mark this one as negative. And where the tail of this arrow is, I'll point the positive at that end. So this becomes positive, other end becomes the negative. Now, I wanted to find whether this oil droplet is positive or negative. So I will try and balance out the forces. Gravitational force will always act in the downward direction. So gravity is always trying to move it in the downward direction. And then it is also given that the oil droplet is suspended in air. So how can an oil droplet stay in the suspended position? It can only stay in the suspended position if the electric force is acting in the upward direction. F is acting in the upward direction. Now, in this condition, the oil droplet will stay suspended. If the if the electric field is in the downward direction, then it won't stay suspended. So I must show the electric field in the upward direction. Now, what's going to happen is this is positive and this is negative. Down here it is negative. This must be a negative on this oil droplet. The charge I must show is a negative. If I show this as a positive, positive and positive cannot attract each other. So this must be a negative. And as I told you, that if the oil droplet comes out to be a negative, it means the electrons are gained. If this was a positive, then the electrons are lost. So hopefully you understand that concept. Now I'm going to solve the mathematical part of it. So if I write the equation, F net is equal to Fg, which is acting in the downward direction, plus Fe, which is acting in the upward direction. So net force, which is equal to 0, and this is Fg is equal to, well, I'll leave it as Fg right now, plus Fe, and I'm going to try and move it on the other side. Fg equal to Fe. And now I will put in the values. Fg is equal to mg, with this one Fe is equal to E divided by Q. And this is from the chapter number 10. If you don't know from where this formula came about, look into chapter number 10 or 11, I guess. 11, yeah, it should be in the chapter 11 or 10. I'm not 100% sure. Most probably, I think 11. So now I'm gonna try and figure out the this value, charge on an oil droplet. So Q oil value will be equal to E divided by mg, and E value is given to me, which is equal to 5.0, well, not 5, it is 1.00. 1.00 times 10 raised to the power 5 and divided by the other values, which is mg. And let me sharpen up my pencil. So m mass value is 8.2 times 10 raised to the power negative 15 multiplied by 9.81. And I'm going to put them in the bracket. Make sure you put them in the bracket, otherwise your answer can be wrong. So Q on the oil droplet, or the charge on the oil droplet, will come out to be 8.04 times 10 raised to the power uh, well, this is, I think I am doing some calculation mistake. This should be, well, see, this is, my apologies, I wrote this formula as wrong. This is E times Q, not E over Q. So E times Q. So I'm going to erase this, and I'm going to try and do the rest of the calculations one more time. So this value will be Q oil, I should write Q oil, this is EQ, equal to mg divided by E. That's how I should write it. Q oil. And Q oil value will be, mass value is 8 point, not 8.2. 8.2 times 10 raised to the power negative 15 multiplied by 9.81 and divided by E value, which is equal to 1.0 times 10 raised to the power 5. Once you're going to do the calculations, you're going to be able to find out the charge on an oil droplet. That comes out to be 8.04 times 10 raised to the power negative 19 coulomb. This number may vary a little bit, so you don't get panic, because if this number is something like 7.99 or 8.09, so don't worry about that. Now we figured out the charge on an oil droplet. This, now I'm going to try and understand how many, I wanted to find out how many charges are there, the number of charges on this oil droplet are. So I'm going to try and understand with that with the help of an analogy. So if I have a bucket, the total mass of this bucket is 10 kgs, and mass of one apple, let's say, is 2 kgs. 2 kgs. If I were to ask you how many apples are there in this bucket, if the total mass of the bucket was 10 kg, so you're going to say 10 divided by 2, that will be 5. Same analogy we're going to apply to our question. This is a big oil droplet which is suspended in air. The charge of one electron is equal to 1.6 times 10 raised to the power negative 19 coulomb, and I wanted to find out how many number of charges are there on this oil droplet, how many of them are there if the total charge is equal to 8.04 times 10 raised to the power negative 19 coulomb. So I can easily find out that now. N times QE, charge of the electron, equal to total charge on the oil droplet. So N value is what I'm looking for, Q oil divided by QE, and that will be equal to N equal to 8.04 times 10 raised to the power negative 19 divided by 1.6 times 10 raised to the power negative 19. So charge of one electron is 1.6 times 10 raised to the power negative 19 coulomb, and this is constant given to you on your formula booklet too. And n value will come out to be approximately 3. So that's how you're gonna solve this question. So because this was a negative charge, so we figured out that the electrons were gained. Now I'm going to take another example similar to this one, so that you can be more confident while solving these questions. So I'm going to take the practice problem 1 on same page number, page 763. So in that question, we are given that the mass of the oil droplet, which is 2.4 times 10 raised to power negative 14 kg, and then we are also given that it is suspended by the electric field of 5.0 times 10 raised to the power 5 Newton per coulomb, and this is in the upward direction, and I wanted to find the sphere has lost or gained the electron. That's what I wanted to find out. So first of all, I'll show the electric field. Electric field is acting in the upward direction. If the electric field is acting in the upward direction, I'll show down here this will become negative, because electric field lines, if arrow of the electric field will always point towards the negative charge and away from the positive. So this down here tail will be towards the positive. And now this is the oil droplet, and this is suspended in air. How can it stay suspended in air? And it can stay suspended in air if there is a gravitational force which is in the downward direction, and then there is a upward force. Only then it can stay suspended, if both the forces are balancing each other. So Fg, we know that always acts in the downward direction, it cannot act in the upward direction. So Fe must act in the upward direction. For Fe to work in the upward direction, this one has to be positive, because negative and positive attract each other. Negative and negative will repel each other. Then I cannot balance this diagram. So I've been able to balance the diagram. I've been able to prove that whatever the answer will be, whatever n value will be, that will be loss of electrons. Positive means loss of electron. If this was negative, it was gain of electrons. So hopefully you understood what I'm talking about. So rest is just a math calculation. F net equal to F E, which is acting upward direction, minus Fg, because Fg is acting in the downward direction. Net force is 0 because the particle is suspended. This is going to move on the other side. Fg equal to Fe, and then Fg value is equal to mg. Fe is E times Q. And now I wanted to find the Q on the oil droplet. Q on the oil, which is mg divided by E. I'm going to plug in the values, and I'm going to get some value from here. And this will be 2.4 times 10 raised to the power negative 14 multiplied by 9.81 divided by E value, which is 5.0 times 10 raised to the power 5. So if I were to do the calculation, I'm going to give you the approximate calculations because I don't have my calculator in front of me. I'm just doing it using my phone. Divide this by 5. So this comes out to be approximately 4.7 times 10 raised to the power negative 19. That's the number I got, Q of the oil droplet. What is the charge of one electron? That is 1.6 times 10 raised to the power negative 19. So Q oil is equal to NQ, which in turn will give me the number of electrons. One charge of one electron is 1.6 times 10 raised to the power negative 19, and Q oil is equal to 4.7 times 10 raised to the power negative 19, dividing both sides by 1.6 times 10 raised to the power negative 19, 1.6 times 10 to the negative 19. So approximately 3 electrons have been lost. 3. Why lost? One more time, because it came out to be a positive down here. So hopefully you were able to understand this question. Now I'm going to take, I just wanted to tell you before I take any question, I just wanted to tell you on the page number 764, the answer in the book for the practice problem is wrong. And it is in the older version I'm talking about. If you are using the online book, it is a wrong answer. It's highly likely. If you have the pretty much the newer version, then it is a right answer. So I think the correct answers, I'll tell you on page 764, should be it should be, I think, 2.8 times 10 raised to power negative 13 Newton for A, and for B it should be 5.8 meters per second square on page 764 practice problems for first one and the second practice problem. That's what I am trying to say here. Okay, and I'm gonna try and match it with my other book also, so that just wanted to make sure that whatever information I'm giving you is correct. So page number 765 is where I'm gonna go to. Page 765. Yeah, I think that should be your answer. So I'm gonna try and take that example also. So let's see. So practice problem one, I'm taking from page number 764. Calculate the net force on the sphere charge, which is negative 5 electron. So charge, you are given this. I'm not going to solve this question fully. I'm going to give you the hints and then you can solve it. So calculate the net force on the sphere charge of negative 5e. So total charge of the oil is negative 5e, means negative 5 times 1.6 times 10 raised to power negative 19. That is the total charge on the oil droplet which is given to me. Mass is given to me, which is equal to 2.0 times 10 raised to power negative 14 kg. And where it shall be placed in the electric field, well, when placed in the electric field strength. So electric field strength is also given to me, which is equal to 1.0 times 10 raised to power 5 Newton per coulomb in the vacuum chamber. We wanted to find the net force on the sphere. Find F net, Fe value. That's what we are looking for. Net force on the sphere. Well, not Fe, actually the net force. So if this is a sphere, how much is the net force, whether it is moving up or down? So F net, this is what we are looking for, net force, which is equal to Fe minus Fg, because Fg always acts in the downward direction, so I've placed it as negative. So now let's try and draw the diagram for this one. It is, the word suspended is not used, so I cannot say that it's gonna, one force is upward, another has to be downwards. So let's figure out where the forces are. And we are given the electric field strength, which is up. Electric field strength is up like this. So if electric field strength is up, so this will be a negative, and then down here it will be a positive. And if this is negative, and then the third thing, gravitational force always acts in the downward direction. And then which direction Fe will act? First of all, it is negative 5 Fe, that's given to me in the question. So this is negative. See here, now this is negative and this charge is negative, so negative and negative will repel each other, so this has to go in the downward direction. So both forces are in the downward direction. See, Fg is in the downward, Fe is also in the downward direction in this case. If you couldn't understand, I'll recommend you to pause the video, go back and re-look into the video. And now we figured out the diagram and we just need to find the net value. Fe is equal to Eq minus Fg. This will also be negative because acting in the downward direction, mg. And I'm just going to place the values in the question now. That will be equal to 2 negative 2.0 times 10 raised to power negative, well, this is not this value, this is 1.00 times 10 raised to the power 5 multiplied by Q value 1.6 times 10 raised to power negative 19 minus mass value is 2.0 times 10 raised to the power minus 14 multiplied by 9.81, and you're going to do the calculations. From here you will be able to find out the number. Let me just quickly see 2 times 9.81 plus, I'm just doing the approximate calculation, plus, well, this will be negative 14. 1.6 times 10 to the negative 14, and then this is 19.62 times 10 to the negative 14. So this number will come out to be 19.62 minus 1.6. Let me see. This is 19 minus 5 is 14. This will be 14. And I'm just gonna look at the numbers carefully one more time. So both will add up, not subtract, because this is also negative. So I was subtracting earlier. 119.62 plus 1.6. So this is 14. Actually, this number will, that's correct. That is 14. It's gonna stay this number, and 19 minus 5, 14. So 19.62 plus 1.6, which is 20, negative 21.22 times 10 raised to the power negative 14. And I'm going to mark this one as, this one will be 2.12 times 10 raised to the power negative 13. I think I might, oh yes, you know where I've made a mistake? See here. This is a oil droplet. This is what I had to use. So then this number has to multiply with 5 also. That's what I missed. So this number has to multiply it with 5 too. So this number will come out to be 1.6 times 5 too, because this is the charge of the oil droplet, which is equal to n times q, and this q is 1.6 times 10 to the negative 19, and this n value is 5. So this comes out to be 8. Now I will get the correct number. So this value is 8. So I'm gonna write down the final number. 8 times 10 raised to the power negative 14, and hopefully you understand what to do after this point onwards. And I've showed you the calculation. This will come out to be 2 point, well, this will be 28 point something 62, something like this, times 10 to the negative 14, and this this is going to move on the other side. 2.8 times 10 raised to power negative 13. And then in the part B of this calculation, it's asking me how much the acceleration will be. So net force is what we figured out from here, which is equal to ma, mass times acceleration. So 2.8 times 10 raised to power negative 13. Mass value is what we know, which is equal to 2.0 times 10 raised to power negative 14 times acceleration, and you will be able to find out the acceleration from here easily. So hopefully you were able to understand this question. I'll see you with another video. Till then, goodbye. And whatever number you're going to figure out, I'll leave it for you guys then. Make sure you put it in bracket and put this one in bracket too while solving. Good day.